Hello and welcome. We're going to do a few practical problems in sine and cos type problems. These are the sort of ones where we've got a couple of composite shapes, two triangles, and we might need to work in one area and then drag the information into the other. This one's not dissimilar, that we've got some information in this triangle, but we actually want to get over here to figure out what this one is. So we've got a link from one triangle to another. Over here first, let's just look at what we've got. We've got a right angle triangle. So in this triangle here, we're going to be working with things most probably SOHCAHTOA. We're probably going to be working with some SOHCAHTOA there, but we can't really get into this triangle. We can't really do anything here because while I've got an angle, and I could figure out this angle as well, I don't really have any sides in here. So I've got to see this side here as the link side between this triangle and this triangle. So just working in this top triangle, I don't have a 90 degree that I know of. So I've got to be working with cosine and sine ratios. That's where I'm going to be at. If I want to use the sine ratio, I need to have a pair of information. So I've got to have a side and an angle. Do we have that? Well, this angle here, I don't have the side. And these two sides, I don't have their linking angle. So the sine ratio is probably not going to be the one for me at the moment. But the cosine rule, where I've got two sides and the included angle, that one's probably going to work for me. So I'm going to label this up as A, B and C. I'm just working in the top triangle at the moment. And I'm going to work this that I need to find A over here. That's the side opposite angle A. So I'm going to write my cosine ratio in that format. A squared equals B squared plus C squared minus 2BC cos of A. Now just to recap on this one, without that there, we're really in Pythagoras. With that there, we're in a non-right angle triangle. Notice the A here links to whichever angle we're doing here. So if I want to figure out A, side A, I need angle A and the other two sides, which is two sides and the included angle. Let's put some numbers in here. A and B don't really matter which way I put them around, but B is this one over here, so I'll put 164 there, squared, plus 135 squared, minus two lots of 164, 135, times the cos of 42 degrees. Now when we get that in, I'll do a quick calculation here with that one, 164 squared, plus 135 squared, minus 2 by 164 by 135 by the cos of 42 degrees. I get an answer of 12,214. 12,214. Now that's pretty big, and we're thinking, hang on, something's wrong here. Not really, because we've worked out A squared, haven't we? So to work out A, I would have to take the square root of that. So if I take the square root of that one, I get 110.52. Now that looks a bit more realistic in here, doesn't it? It fits the side lengths that I'm expecting. So I've got 110.52. Let me add that to my diagram. That's going to be A here. So now what I can do is just look in this triangle because that piece of information is there to link. So if I just look in that right angle triangle, I've got that one there. I've got 110.52 there. I've got 35 here, and I want to find that out. So using SOHCAHTOA, well, I'd probably do cos is adjacent over hypotenuse. So I think this is the part we're going to use there. Cos of 35 degrees is equal to adjacent 110.52 over x. Quick rearrangement here, move the x up to top, move the cos 35 down below. X is going to equal 110.52 divided by the cos of 35 degrees. Now keep your answer on there because I've got all the decimal places there for this answer here. Always try and keep them there, especially on a class pad. Go back, get the right answer. So I'm going to divide that by the cos of 35 degrees. Keep your calculator in radians. I come out with 134.92. 134.92. Which would be the length of this side here, and that approximately fits what I'd expect. So I'd be reasonably confident in that answer. So to recap, I'm working here first using the right rule or ratio that I need to get a side or perhaps an angle that will link me into the next triangle. Once I've got that, I can pull that triangle out and work with that one, get down to an answer. There were no units on this, so I might just put units after it. That tells the marker that I understand that I'm measuring something, so there will be some units, but none were given here, so I'm just making that note there. The next question over here has two triangles, or really three triangles. There's 1, 2, and then the big one over here, 3. So we've got three triangles, couple of angles, couple of sides. Because x is over here, I'm guessing I'm going to need a bit more information in this triangle here. I've only got a side length. I can't really do much with only a side length, so I want to get some angles or something in here over to this triangle. Straight away I see a real simple one to work with, and the real simple one is the fact that in this triangle, this small triangle, I have two angles. So if I've got two angles out of a triangle, I know there's got to be 180, so if I do 180 degrees minus 45, I get 135 degrees. So that means this angle here has to be 135. Now then, that means that this is a straight angle which also has to be 180. 180 minus 135 is going to get me 45. Now as a side note, this is what we call the exterior angle of a triangle. So for this smaller triangle, if we extend one of the lines, the exterior angle is equal to the sum of the other two. So you could have missed that mid-step of the 180 minus part. So I've got an angle and I've got a side. I still can't do anything here because this is not a right angle triangle and I don't have enough information to use either the sine or the cosine rule. So let's see what we can do. Well, I've got three angles here and I've got a side. So I think I've got a pair of information and another piece of information. So I reckon using the sine ratio, I can write the following. I can write 82 divided by the sine of 135 must equal, that's that pair, must equal this pair here. Now I'm going to call this A, must equal A over the sine of 20 degrees. So it's this pair here, the ratio between this pair has got to be the same as the ratio between this pair. Let's rearrange, and you'll notice I put the A on top. I kept my sides on the top. That makes it easier if you can do that. A is going to be equal to 82 times the sine of 20 divided by the sine of 135. How did I do it? I'm multiplying this side by sine of 20, that cancels, and I've got to do the same over here. Let's get an answer for that one. 82 multiplied by the sine of 20, I'll press equals just to make sure it does that, divided by the sine of 135, I get 39.66. 39.66. And again, in the concept of this question, that seems about right. This side here is 82, that's definitely shorter than it, so it seems about right. This has got metres on it, so I'm going to add metres there as well. So what have I got? I've now got a side here as well, so I've got 39.66 there for that side. Can I work something now? Well, now I've got two sides and the included angle. So I should be able to use the cosine ratio. So I'm going to write x squared equals, now it's very similar to this one over here. So it's going to be these two sides, and remember the order we put them in doesn't really matter. 74 squared plus 39.66 squared. Now this 39.66, I'm going to keep all the numbers in my calculator. I'm not going to get rid of them. I'm going to keep all of those. I might only write 2, but I'm going to keep the rest. 39.66 there. What do we got? Minus 2 lots of 74 times 39.66 times the cos of 45. And then let's do that on the calculator. So I've got the 39.66. I'm going to use that first. Now, on a class pad this is a bit easier, but I kind of want to use it twice here. So I'll put it into memory and I'll use that twice. So I need to square that one, plus 74 squared, minus 2 by 74 by that 39.66. So I've got all the numbers on the screen so I can put them in, times the cos of 45 degrees. And I get an equals for that. And again, it's a really big number, 2,898. 0.36. Now, of course, that's working out x squared. So similarly over here, I've got to take the square root of that. Take the square root of the answer equals, I get 53.84. Now again, check the validity of that. 53, does that seem about right? Yes, it does. This is only a sketch. It seems about right. So it means that I can be reasonably confident with that one. Once again, this is in metres, so I should answer in metres. Oops. And that seems to finish up that question. It got what we wanted here. I've used the sine ratio and the cosine ratio. I'm pretty confident of that answer. Hope that video helped you. See you later.